All right. Shh. I think I'm recording. Yeah, I'm recording. All right, here we go. Shh. You guys settle in. Shout out to Liz. Shout out to Liz. All right, stop. It says which expression shows a decimal equivalent? 13 over 32. Oh shoot. I gotta plug this in. I think we'll start the video over too because okay, there we go. I had to connect it to my projector. All right. No, we won't start over. Leave it in there. This is what real people do. So shh, guys, be quiet. I need to figure out what the decimal equivalent to that is. What do I do? I'm going to divide the numerator by the denominator. So 13 divided by 32 is 0.406, probably rounds to 0.41. So, oh, wait a minute. Which one do we choose? 0.41 or C is the exact, right? C is the exact decimal. Do we pick A or C? C. Okay, see how that works? Now, did it say round to one decimal place or to the hundredths or two decimal? It didn't say that. It didn't say that. And also, you don't realize this, but whenever they say equivalent, they want stuff that equals. And when they want stuff that equals, it didn't say the approximate value. It said the equivalent value. So that means you want it to be exact, right? That's later on, you guys will learn more about exact values versus approximate values. Which fraction equals a repeating decimal? So that's an interesting one. How do we figure that out? Yes. You use your calculator. Now, I suspect, I have a hunch that it's D because D reduces down to something over 9. 9 always has a repeating decimal if you have 9 in the denominator. So let's do that. Let's do 18 divided by 81 on our calculator. Ready? 18 divided by 81. Now, you would do this for all four, okay? You would do this for all four options, but sometimes 0.3 has a repeating decimal, or I'm sorry, not 0.3. Some, like 1/3 has a repeating decimal. 9s have repeating decimals. Something over 11 has a repeating decimal. So this would be, oops, wrong pen. This would be the correct answer because it's 0.2 repeating. Now the next one says, which number is a perfect square? Now that means if I take a square root, we'll have an integer. Actually, we'll have a whole number. Well, let's just crank through it. Square root of 249. So you guys do this, play along with me at home. Plug these in the calculator, see if you could beat me. Nope, that's not it. The next number is 265. Well, I'll do 256. I think it's 256. 256. Yep, 16 times 16. So circle 256. See how that works? So this is an interesting one. The square root of n is equal to 3/2. What is the negative? What is the negative of the square? Well, isn't that just negative 3/2, right? How you guys feeling about this? All right, number 5. It says a square playing field has an area of 1255. So I'm going to stop right there. Square means that the side length is equal to the side length, and we know that the area is equal to the side times the side, or s squared. And we know that the area is 1255. And it says about how long is each side of the field. How do I solve that? Well, let's write it out. I'm going to say 1255 equals s squared. What do you think we do? Yeah. Oh, what do we do to solve for s? Yes. Well, you raised your hand. Kinda. How do you undo a square? Yeah, she made the symbol. She said, yeah, square root. So we're going to take the square root of both sides. When you take the square root of both sides, you'll get the answer. So the square root of 1255 is, and then the square root of this undoes, right? They're inverse operations. So the square root of s squared is just s. And then we got to figure out the square root of 1255. So let's do it. Second, x squared, it gives me the square root symbol. And then I say 1255, 35.420, blah, 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 blah. It's early in the morning. 32, about how long is each side? So this is interesting. Am I reading it right? Yeah. So it says 35. The answers on the worksheet has 30, 35. So which one do you think it is? A, B, or C, or D? C. Okay. Now notice we can say that because it said about. It didn't say what is it exactly. What does it equal? What is the equivalent? It said about. So that means we can round. Did I say 32? Yeah, there's something wrong with me. It's early in the morning. I'm not perfect all the time. So what's the best estimate of the square root of 35? Well, I would guess it's pretty close. What's the square root of 36? 6. So I would guess that it's pretty darn close to 6. I'm going to guess and say it's either C or B. How can we find out? Take the square root, our handy dandy calculator. Square root of 35. 5.91. 1, 2, 3, 4, 5. All right. So what do you guys think the answer is? Well, that's the thing. It's either C. Yes. What? You're raising your hand. What do you think it is? That's the thing. Do we round it? And what do we round it to? 6. I would say it's pretty close to 6. Actually, the answer key says it's 6. Wow. It says it's D. Oh my God, okay. So smart. You lied to what you said. It was. I said I think. I said I think. Well, it says best estimate. So if we round it to a whole number, here's the thing. If I round it to a 10th, it would be 5.9. That's not one of my choices. It would never be 5.8 because it's greater than 5.8, and we wouldn't round down. It's definitely not A. 9.5. That one's a tough one. I mean, if you round this to the 100th spot, it would be 5.92. But if you round it to the 1 spot, it would be 6.0. So in all the rounding that you do, D is actually the correct answer. Yes. Do you have a question? You have a question?
Okay, so I have a theory.
Yep, we're recording. You got 5 seconds. Go.
Okay, so since the square root of 35 is 6, divide 35 by 5 and we get 6.
That's actually 7. 35 divided by 5 is 7. You should stop theorizing. Leave it to the professionals. All right, here we go. Number 7. We got to get this done today. Stay focused, my little squirrels. I have a math theory. Oh, no, it's actually... Yeah, because you guys have the attention span of a chipmunk. You ever watched a squirrel? Which value of n will make the rational number negative 17 over n an integer? Now that means when we do the math, I think it's C. So when we do the math, it's got to be an integer. So if I say negative 17 divided by 170, what does that reduce down to? Oh, no, wait, that's backwards. No, it's not that. So hold on, we got to rethink this. None of them, actually. Yeah, you got to do the math on that. If it was the other way around, if it was 170 divided by negative 17, that would be negative 10. That's what Mr. Adams was thinking. So it's actually D. All right, moving on to number 8. Moving on to number 8. So it says, which of these is most likely to describe the change received from a cash purchase? So cash purchase could be like, I buy something and my change could be something like $2.35, right? Or it could be just $2. We don't know yet. But more than likely, it's one of those, right? So it could be a whole number, could be. But remember, it says which one is most likely. It's not going to be a negative integer. It'll definitely be a rational number. It's not going to be pi or the square root of 3. So which one do you think it's most likely to be, A or C? Yes. C. Yeah, it's most likely to be C because, you know, when you buy stuff, it's always like $2.95 and then there's tax, so there'll be change. Now, if it was and let me highlight this, write this down. 235 is a rational number. Technically, $2 is a whole number. Very rarely do you get exactly $2 change or $3 change. You do, but the one that's most likely is the rational number. All right, next one. Which term for set A makes this diagram true? Which term makes this true? Is there a set of numbers inside the irrational numbers? You have your hand up. What do you think it is? Well, integers are not irrational numbers. So remember, whole numbers are not irrational numbers. Remember, irrational numbers are pi or the square. Well, A is a subset of irrational numbers. But if you remember in your diagrams, there are no subsets. So it's D, none of these. Okay. So 10 says, which statement is false? Some integers are irrational. Are integers irrational? Negative. So that's the false statement. Yeah, that was easy, right? So it says, which number is between the square root of 20 and 17 over 4? Let's find those decimals real quick. So I'm going to say 17 over 4. And that's going to be 4.25. And then the square root of 20. And that's going to be 4.47. And then, oh man, you're supposed to go through all those on your calculator and figure out which one it is. Well, pi is 3.14 plus 1.2. Let's see if that works. So if I go pi, so hit second, you guys should be doing this too, plus 1.2. That fits in the middle, doesn't it? Well, I would guess that only one of these does. So we're going to go with B. And that's what the answer key says. But you guys know that when you do this quiz by yourselves, that you're going to go through each one of these and find a number that fits between 4.25 and 4.7. Yes, you have a question? Go ahead. It says, which is the greatest number? Again, what I need to do is convert all of these to a decimal, right? And then find the one that has the greater decimal. So I happen to know, well, let me just model it for you. So the first one is 50 minus, oops, just one minus sign, 16 pi. Okay, that's a negative number. Yep. Then the next one is negative square root of 20 plus, yeah, that's okay. They're doing that on purpose. 1 divided by 2. Is that right? Or no, it's, yeah. And so that's a more negative number. Then the next one is 16 minus the square root of 410. That's going to be about 20 something. That's even more negative. And then lastly, we have 7 divided by 3 minus, oops, not minus, or not divide, minus 7 pi divided by 3. Yeah, and yeah, so you guessed it. The less negative number is the greatest. So it's going to be A. Very good. Yep, A was the least negative. That means it's the greatest. Almost done, halfway done. Ready? Turn the page over. By the way, how does it feel to go over this? Are you guys getting it? Can you do it on your own by yourselves? Depends on the day. All right. Today is not the day. All right. Shh. It says, is 11 over 28 equal to a terminating decimal or repeating? Explain how you know. Well, what we need to do here is plug it in the calculator. So it was 11 divided by 128. Hit enter. Does that end? Yes. So that means it terminates. Is it repeating? No. So let's see. For 13, it says, is it a repeating decimal? No, it's terminating. So you would say, explain how you know. Terminates. Terminates means, that's a fancy way of saying that the decimal ends, right? Okay. Now, there's an extra thing in here too. They say that the denominator 128 is a power of 2. I would be happy with just terminate. Terminal. How do I write 2 and 1/6 as a decimal? Does anybody remember? Yes.
116.
Yeah, I said it wrong, but that's okay. What do I do? Plug it in the calculator, right? Oh, I got one more thing I got to do, though. My screen is slowly getting darker and darker. I got to plug in my power. We're going to lose some juice. There we go. Oh, there it is. All right, so, yeah, we got to plug it in. So 2 plus 1 divided by 16, right? That's how you do it. Well, bam, with the bacon sizzle, I got 2.0625, right? That's the answer. Express 11 over 30 in decimal form. Oh, gotta do the same thing, I guess, right? So get our handy dandy calculator. We're gonna do 11 divided by 30. Well, bam. Ooh, that looks like. Now, what do you think that is? Not terminating. Repeating. Right? When we have that many and it rounds up at the end, that's technically 0.36 repeating, because only the 6 is what repeats. We only put the bar above the 6. Okay? Number 16, how many digits are there in the repeating block of the decimal equivalent of 3 over 7? So first we got to use the calculator. So we're going to say 3 How come when I hit my calculator, I don't see everybody hitting their calculator? Grab those bad boys. All right. So here's the thing. I've got 0.42851, and then the pattern repeats, right? You don't round it. I mean, the calculator did, but this is what repeats. Yes. In that cabinet. If there aren't any, there's some back there by the hand sanitizer. All right. So we need to count how many digits that is. So it's 1, 2, 3, 4, 5. Wait, let me count again. 1, 2, 3, 4, 5, 6, and then the pattern repeats, right? So let's look at that real quick. I have 4, 2, 8, 5, 7, 1, and then it has 4, 2, 8, and the calculator rounded it to 6, but we know that the pattern repeats. So that is 6 digits, right? Any questions on that one? You can go out in the hallway if you need to. Whoa, find the square roots. So what they're saying is, what's the square root of 9 over 4? So then we could rewrite that as the square root of 9 over the square root of 4. What's the square root of 9? So 3. So the square root of 9 is 3. And then what's the square root of 4? 2. Am I done?
No.
Why?
Oh yeah.
No.
What?
What do you think?
I think we need to make it a mixed number because it's improper and that's where.
Wrong.
What?
Yes. What? No. Yes. No.
Be louder.
Let me show you. 3 over 2. We're looking for numbers that when you multiply them by themselves, you get 9 over 4. 3 times 3 is 9. 2 times 2 is 4. Right? What about 3 over 2 times 3 over... Oh, wait. What about negative 3 times negative 3? What would that equal? Positive, yeah. So we're half right. It's 3 over 2 and then negative 3 over 2. So whenever you take the square root, you got to do plus or minus. That's the one that not everybody, some people caught it, did it right. That's what you need to remember. And now I'm scared because you guys are going to get this one wrong. Say after me, whenever you take the square root, plus or minus. Okay, thank you. All right, let's move on to number 18. Actually, technically, it's even root, but it's all right. 2 is an even number. You could take 4th root, 6th root, 8th root, 8th root. Number 18, the number line is numbered in tenths. Describe where you would plot this number. Well, we got to take the square root of it first, so let's figure out what it is. Second square root button. What was that number? 87.35. And it's in tenths. So what they're saying is round that to the 10th spot. Or you could place it somewhere, right? So it's let's write this down. It's 9.346 approximately. Okay? It's approximately that. So if the number line is in tenths, that means somewhere on the number line you have 9.3. Somewhere on the number line you have 9.4 because it counts by tenths, right? 9 and 3/10, 9 and 4/10. Where do I plot that point? Yeah, in between those two, leaning a little bit more towards... Oh, actually, it's leaning a little bit more... We'll just make a big dot. A little bit more towards the 3, right? It's close. It's almost smack dab in the middle, but it's, I mean, if you were to round it, it'd be in the middle, but it's a little bit more towards the 3. But in between those two, right? Next one says estimate the square root of 250 to the nearest 0.5, to the nearest half. So I'm going to take the square root of 250 and I get 15.8. If I round it to the nearest half, what would that be? Well, is this number closer to 15.5 or is it closer to 16.0? 16.0 it is. Okay. That's a fairly new concept in mathematics. All right, number 20. Classify blank as a whole number, rational number, integer, blah, blah, blah. What is the square root of 64? No. This reduces to 8 over 5. Now, 8 over 5 is not an integer. It's not a whole number. It is a rational number. It's not irrational because it terminates. How do I know it terminates? Well, because I'm a math teacher. But if I go in here and I say 8 divided by 5, I get 1.6, right? So that's how we know it's rational. It terminates. And it says, right, I'll apply. So it's rational. And what's the other type of number? Real. Very good. You guys are getting the hang of that. Usually kids struggle with that, but you guys seem to, except for the irrational numbers. That's a little hard for you guys. Yeah. Yeah. Yes. All numbers are real until the 11th grade. There is one number called the imaginary number. It's part of complex numbers. It has the letter I. If it doesn't have an I, then it's a real number. I let me finish this and I'll explain that to you. That explanation is a little more complicated than, but well, I can tell you. I is an imaginary number that is equal to the square root of -1. Tell me what two numbers you can multiply and it equals -1. No, there is no two numbers because whether it's a positive or a negative number, when you multiply it, when you square it by itself, it will always be positive. So because you can't take the square root of -1, we call it I, which is very helpful in certain fields, especially electronics and physics and stuff like that. So anyways, problem number 21. Hold on, guys. We're almost done. Don't lose focus yet. Write the principal. What does principal square root mean? Positive. No. Write the positive square root. We know now, because Mr. Adams taught you, that whenever you take the square root, you have a positive and negative solution. So what we need to know is what is the principal square root of between the integers of 320 and 325, and which of these is rational. So we just got to take the square root. So I'm going to say the square root of 320, 17.88, and then the other one was 325, right? 325. That one probably is going to be irrational. Oh, no. I apologize. I see what they're doing. Okay, so I've read the question wrong. So we're trying to find a number that's trapped between 320 and 325. There's a perfect square that's trapped in between there. We have 17.88 and we have 18.02. What what one of those numbers in between, think of a number in between those that is rational or even a whole number. Yes. 16 is not between those two numbers. What about 18? If I square 18, that's 324. So technically, in other words, they're saying if you go 320, 321, the square root of 322, the square root of 323, the square root of 324, and the square root of 325, one of those is rational. Well, this one, the principal root is 18, right? Because 18 squared equals 324. So that's what they're saying. It's a poorly worded question, but that one you would get wrong, probably. That one Mr. Adams would be nice about and say, well, if you're close, you're close. Okay, moving on. It says, which formula contains a rational number that is not an integer? Okay, so here's the trick. Pi is irrational, right? It just makes bad decisions. No, that's a lame joke. Pi is irrational. So anything that has pi in it is irrational. And it says which of these, and so which one is it that isn't an integer? Well, it's either this one or this one, but 4 is an integer, but 1/2 is not an integer. So it's the formula, the area of a triangle, 1/2 times BH. 1/2 is not an integer, right? 23, which of these formula contain both rational number and irrational number? Anyone with pi. So we're going to say the area. Oh, it's got to have rational and irrational. Rational. Well, all of them. Yeah, anyone with pi. So the area of a circle. Well, are they including that one? Because technically the formula doesn't. That's a tricky one. Area of a triangle, volume of a sphere. Why doesn't it include the surface area? Oh, it does. Wait. Volume of a sphere. Area of a triangle. Oh, you know what? We forgot one on 22. Volume of a sphere, too. No, that's not right.
What is that the answer key?
It's the perimeter. No, that was right. Yeah, I'm looking at the answer key. That's the problem I'm running into. Which formula contains a rational number that is not an integer? Oh. Well, what they're saying is this contains 4/3. I guess technically they're not. Maybe I'm reading the question wrong. I'm reading has a rational number as not having an irrational number. So technically, this one does have a rational number because 4/3 is a rational number. It doesn't say that you exclude pi. And so, with that same line of thinking, which formulas contain both rational numbers and irrational numbers? This one, because it doesn't have a number per se, technically we can have an implied one. It would be the other ones that have pi. So surface area, yeah, don't just scribble that one out. According to the answer key. Surface area and volume of a sphere. Yes, do you have a question? Misspelled the word sphere.
Sphere? What is that weird, like, smiley face? It's like upside down. That's pi.
That's pi. This is pi. Well, you're probably used to seeing it like this, but technically it's written like this. Anyways, let's move on to, we only got a couple more questions, then we're done. It says, what kinds of numbers would not be sensible values for variables? What kind of numbers would not be sensible values for variables? In this, and I think they're referring to the formulas. So most of these have a base or a height or a radius, right? That's what the formulas say. This is kind of a trick question, but negative numbers. I'm never going to have -3 diameter. I'm never going to have the height of a triangle be -5. They're always going to be positive. I put negative numbers. I never have -3.25. So it says find an integer between square root of 30 and 4/3 pi. So now that one is easy. I'm just going to plug this in the calculator. So I'm going to take the square root of 30, and that's 5. So I'm guessing it's probably 6. Let's see. 4 times pi divided by 3. Oh, no, my mistake. It should be 5, right? 5 is between those two numbers. That's an integer, correct? All right, good. That's a 5, not an S. That doesn't make it look any more. 5. 5. All right. Now, here's another problem that everybody got wrong. To figure greatest to least, the easiest way to do this is to figure out what the decimals are. So I'm going to write this down. So we're going to take, but we have to write them down in their original form. In other words, I'm going to say the square root of 150 and figure that out. So the square root of 150 is approximately 12.24, well, 25, if we round it. The next one is 11 and 4/9. So I'm going to say 11 plus 4 divided by 9. And so that is 11 and 4/9 is approximately 11.4 repeating. And then 4 times pi, so I'll say 4, that's going to be 12 something. That's going to be 12.56. Okay, 12.57. So greatest would be 4 pi, right? Because that's the biggest number we have. So I'm going to write down 4 pi. What a lot of you guys did is you would write down the 12.56. That's wrong. We're using the decimal to figure it out, but this is a rounded number, which is not the same as 4 pi. Next one would be the square root of 150. And then lastly, 11 and 4/9. That's how you do that one. Oops. Any questions on that? Can you sleep? A nap time? Well, class is almost